All right. Hello, everybody. How are you guys doing tonight? We're going to start a little bit early tonight. Sorry for the delay there. I ran into a couple of issues that I needed to sort out before we could actually go live, but we are live now. So thank you very much for joining. For those of you who are new to the stream, or if you're watching this on YouTube, this is a series where we are building a game engine from scratch. With minimal use of libraries. There are a couple libraries we're using, a couple small libraries that we're using for things like loading images and fonts, since that's not something that I found valuable to do manually. But other than that, we are writing everything from scratch. So we are writing a game engine that uses Vulkan. And where we're at right now is we are actually in the process of creating a file format for our scenes. So in previous streams, we basically had created the ability to have what we call a simple scene, which can directly add various types of objects, whether it be lights or skyboxes, meshes, things of that nature. And now we're actually going to have the ability to load in a file with those configurations instead of having to do them in code like we do right now, like this. So that is what we're going to work on tonight. And yeah, like I said, I wanted to start this stream a little bit early tonight and see how far we can get, right? So I don't know that I'm going to stream all the way till 11 tonight, only because I have been sick for the last few days and I'm pretty tired, but we'll see where we wind up. Anyway, before we move on, I do want to take a quick second and... Oh, Smudge, thank you so much for subbing for 2 months with Prime. Thank you for that. I appreciate that support. Thank you so much. Speaking of which, so I do want to take a second to thank our supporters. So we have various levels of support, starting with the partners, who are the top tier on Patreon and YouTube. So that is Caden Parker, AR Sleo, Garbolis Inc., Paul S., Super Awesome, and Wenchang. And then we also have all the other supporters here listed on the screen as well. These are the fine folks that are supporting the channel financially, which includes YouTube memberships, Patreon, and of course, Twitch subs. So, I do also want to take a second and thank each and every one of you who are following the channel and this project, whether it's here on Twitch, on YouTube, or both. Your support there, just by following me and spreading the word, is greatly appreciated. Without you guys, this project would not exist, and I would not be able to do this. So thank you to all of you. All right. So, with all that said and done, tonight we are going to go ahead and finalize our scene format, and then go ahead and implement the loader for it. Get it registered and all that so that we can actually load these things and change the file and see it in the game. So, last time we sort of had described we're going to have this sort of format where we have these section sort of headers where we define a section beginning and end, and then there are variables in between it. So we have a scene with just global scene information here. That's usually at the top, although I don't think I'm going to make the order of this matter. Because it really doesn't. The other thing is so we have things like skyboxes, where we define the properties that are needed for that, directional light, where we define things like color, direction, etc. But one thing that we kind of brought up on the last stream that I didn't fully know how I was going to implement it at the time was the transform. So one thing that we had sort of discussed was having this sort of sub-level of transform like this, where we have the properties split out. I don't think that I'm going to support that for right now. I think the way that I'm going to roll is this compressed format here. And that is just to keep things simple. So it'll allow us to basically read this in all in one line and not have to do a whole bunch of extra parsing. So we're going to go ahead and keep it simple. And with that, we are also going to, before I delete this, down here. I do want to talk about parenting for a second too. So we're going to use position x, y, z, and then quaternion x, y, z, and w. So we're going to use quaternions to define that here, which is not the most intuitive, but bear in mind we are eventually going to have an editor to sort those things out for us. So I suppose we could maybe do a count on the fields and try and determine whether we're using quaternions or Eulers. Maybe that's something we'll build in, but for right now I'm going to roll with quaternions. And then we're going to have our scale, x, y, and z, right? So we may wind up having two different versions of this, where we have ex, ey, and ez, and then no w. And if that is defined, then maybe we use Euler angles. So I haven't really decided, but all right. So with all of that, I do want to take a quick second and talk about parenting, because right now the only things that have a concept of a parent is a transform. And I've talked a little bit about wanting to split meshes away from their transforms, and I think that's something we're going to eventually do, but for right now they are still linked, and so we're going to kind of take advantage of that. And so what we're going to do is, as we're loading the mesh, if we find this parent field, then we're going to go ahead and store it off in a configuration object. And then once every object in the scene has been read into configuration, we are going to basically seek out the transform for the named object here, seek out the name object rather, and then seek out the transform for that, and then parent it that way. So we'll see how that's going to work. I've got an idea of how I'm going to put that together, but that is the gist there. One more thing that I do want to go ahead and put in here is I have the directional light, but I do not have the point lights. So I'm just going to go here to testbed main. And I think we did the point lights right here. Okay. So let's do, I'm just going to copy this real quickly and go back to our simple scene. And I'm just going to extract the data out of it, right? So we'll say point light, and then we'll go all the way to the bottom, and we will close that. So our properties are going to be color, which is a vector 4. So we're going to parse that out. We don't need the f's or the commas, because we can just parse these numbers directly from the string itself. We need the position in this case. So again, we don't need the f's or the commas. So there we go. All right, so we'll just parse that. And then we have our constant float, which is just 1.0. And we have our linear, which is 0.35, our quadratic. And eventually I'm probably going to wind up changing these properties into a little bit better names, so that it's a little bit more clear what they do. We also have, padding was something that was in the structure itself, so we don't need that. The only other thing that we need is name. So we'll put that first. Doesn't have to be first. These properties can be in any order, but we'll call this point light 0. And we're going to get rid of some spaces here, just to not only reduce file size, but simplify our parsing a little bit, right? It's less characters to parse. And that's it. So that is what a point light looks like. So we have one of those. So I'm just going to paste this in here 2 more times. And I think the only thing that actually changes between these is position and color. So I'll do 1 next, which is the position here. Looks like the only thing that changed was the x-axis on that. It just gets changed to positive. So we'll change that. And then the color is green. So we'll change the color to green, right? This is RGBA. And then I think all the other properties were the same. Yes, okay. And the same thing is true for the third light. So we're gonna go ahead and keep this as well. Not to backseat code, but line 33 missed an F. Not so, oh, yep. And 42 as well. Oh, a couple of them. Sweet, thank you. Yeah, I'm always going to miss stuff like that for sure. So I don't mind if you guys correct me. Like I said, this is an interactive stream. So if you guys see something, feel free to ask about it or call it out. Okay. So I think all this one does is just make this positive now, and then it's blue. So we will make this positive, and it's blue now. Okay. And there are all of our lights. So basically what we should wind up with is something that looks very similar to what we had before, minus the rotating cubes, right? We're not going to actually create those in this level. All right, so now we need to start talking about how we're going to actually accomplish the loading, right? So typically with our other systems, we have a resource, and then we have loaders for each one of those resources. So I think I'm going to wind up kind of doing the same thing here. And we're going to treat this as a resource. And I think what we're going to do is we're basically going to have configuration objects for each one of these types because we know about all the different types in here. And we'll basically populate those structures and keep lists of them. And then when it comes time to initialize the scene, we'll have all the data that we need. We can just sort of look through that structure to get what we need. So that's probably going to be the first thing that we do. So what I'm going to do is I'm actually going to copy the configuration for all of this stuff. And I'm going to go to, should we do resource types? I guess this is probably where we should add it. We've put all of our other ones here. This file's getting kind of large. We may have to split this up at some point. But for now, this is fine. So I'm going to call this, well, type def simple scene config, right? And it's a structure. And you know what? I'm going to split this. So we'll split right, close that, so we can actually kind of see what we're working with side by side. So this just has a couple of properties. So it has a character array name, and then it has a character array description. This will also have eventually other properties like fog properties, for example. So anything that's global to the scene would sort of go there. So that's it for that for right now. And then we just need to add the configuration for all these other types. So we'll type def another struct, and we're going to call this skybox scene config. I guess we'll call this simple scene config. It's a little bit verbose, but I want to be explicit that this is only to be used with simple scenes, right? When we go to set up our ECS system with an ECS scene, we're going to do this completely differently, right? Those are designed to operate separately from one another. So pretty much all of these is going to have a name, so I'm just going to copy that. And then this is also going to have a cube map name. And that is it for Skybox. And so we can only have one Skybox scene per scene. So I'm just going to put this here and say Skybox config. Right? And so for each one of these, we're either going to take in a single one or keep an array of them. So we're going to type def another struct. We're going to call this directional light simple scene config. Boy, that's kind of long. I may have to think about that naming convention. Right. Of course, this is going to have a name. This is going to have a vec for color. It's going to have a vec for direction. And that's it. And we're only going to have one directional light config, so we're going to put that here. Directional light config. Okay. Do we not have our math types in this? I thought we did. Red Candy, welcome. How are you today? So what we're doing right now is we're basically setting up structures to be able to parse this scene format, this simple scene format for our engine. So we already have the logic behind simple scenes created. So this is basically going to be giving us the ability to define these things in a file and load them that way instead of having to do them in code. So that's what we're working on right now. You're very well. Good. Glad to hear it. Let's see. So we do have math types. So why? I guess IntelliSense is just tripping. Let me build this real quick. Okay. There we go. Okay. My highlighting was broken for some reason. All right. Is this for YouTube where you must stay in topic? So this will wind up on YouTube. What I'm doing is I'm archiving all of these streams. So I'm basically doing the dev here on Twitch, and then it gets downloaded and re-uploaded to YouTube as an archive. And those are generally a couple of weeks behind when I actually stream. I can't stream to YouTube at the same time because Twitch affiliate or partner doesn't actually allow you to do that. So yes, this will wind up on YouTube. And I do stay on topic in terms of what we're working on here for the most part. Although I'm thinking at some point I probably will have like a just chatting stream or something like that where we can go off topic, if that's what you're wondering about. Okay, so since we're doing lighting, I'm actually going to do point lights. So I'm actually just going to copy this guy real quick. Point light simple scene config. Of course, this has a name. It has a color. It has a position instead of direction. And then it has a F32 constant, a F32 linear, and a F32 quadratic. Okay, and that is our point lights. So these, we are going to keep a D array of them. So we'll call this point lights. Okay, so we'll have that. So that'll take care of these guys. And then the last one we need is a mesh. So I guess I can put that, yeah, I'll put that here. So we'll have a type def struct mesh simple scene config. Right, we do have a name. And then we do have a resource name. And that's going to be the name of the mesh that actually gets loaded, right? So this is the name of the instance. This is the name of the mesh that gets loaded. We're also going to have a transform. I'm going to call this xform. And actually, no, I should probably call that transform. I don't like that that's the same word. That's all right. I'll stick with it for now. And then we're going to have a character array parent name. And that's going to be optional, right? And of course, similar to our point lights, we're also going to have a darray of these because we can have multiples, so meshes. All right. The other thing that I want to do is, I think for our scene file, for the file itself, we probably ought to have some sort of version, because a lot of, well, I don't know that I want to support version with this. Maybe. I might come back to that. Because if we update the format or something, maybe the version will need to be updated if it's a breaking change. You know what? I'm going to add it to scene. It's kind of the header. I want to do that. Maybe it should have to be the first line. Right? Like maybe we say exclamation point version, and that has to be the first line, right? We'll say exclamation point version equals 1. The other thing we want to do is support comments. So we can say this is a scene file, right? And then we can also say the version of the parser to be used, right? So we have comment support, just in case. So basically any line that begins with this, we're just going to treat as a comment. And then we have to have version defined. I'm going to say, like, we can have comments first, but we have to have version defined before we actually start loading anything. So I think if we start loading any header section and we haven't actually set the version, then we should probably throw an error. So with all of that, we have all of these structures here. I think we can actually start working on a loader. So if we take a look at some of our other loaders, the one that comes to mind is, I want to say it was materials that were kind of similar. TNT, hello, welcome. You are here. Welcome, welcome. So was it material config that I was kind of modeling this after? No, it wasn't material config. It would have been shader config, I think. So we can actually reuse some of this logic because we actually have this sort of variable equals value logic already. So I think we can model our loader after this and just modify it to do this. So I'm going to go with the shader loader as an example. So let's get that opened up. And we're going to go ahead and just actually do this. Right, I'm just going to copy this and create a new file. And I'll call this simple scene loader.h. Loader for simple scene files. Cool. All right, and we're going to call this resource loader simple scene resource loader create, and simple scene in the comment, and I think that is all we need to do at that level. So what we can do now is we can go back to the shader loader. We're done with the H file. You look at the shader loader C file. And I think what I'm actually going to do is I'm just going to copy this whole thing, right? Because it's easier than the sort of scaffolding this from new. And we create a new file, simple scene loader.c. We're going to include simple scene loader.h. Get rid of the shader loader. So we will need the logger, k-memory, string, resource types, resource system, math, loader utils, darray, and file system. We're going to need all of that. So that's good. Shader loader load. This is going to be simple scene loader load. Right, so we'll rename that. So our format is going to be KSS, I think is what I'm thinking. Is that light in the background new? Yes, it is. Yeah. My wife actually bought those for me this last week, actually. Yeah. So yeah, those are new. I have one there and I have one on the other side, which you guys actually can't see. But yeah, there's one on that side as well. It's pretty cool. I figured it would add something to the backdrop, make it a little less boring, right? So yeah, I think we're gonna go with KSS for our simple scene. We have K simple scene here, but that's kind of long. The only thing is, we were talking about a potential binary format. So maybe we have KSS and KSB to determine which one we actually use. But for right now, I'm just going to use KSS, right? And I'm actually going to rename. Can I do it here? No, probably not. KSS. All right. So we have that resource system-based path, self-type path. We'll configure that in a minute. Here's the open. This is going to be simple scene file for loading. We are going to probably need to, yeah, let's change this from shader config to simple scene config. All right, so we're going to allocate that. Set some defaults, create arrays, right? So we need to go ahead and do that. So we'll say resource data. Description, we'll set to just an empty string. Resource data, name. We're going to have that be optional as well, but we're going to default it to the name here, right? So we'll say string duplicate. We'll default it to that, right? And then if we have one that's actually defined that's separate from the file name, we'll go ahead and take that instead. So we have resource data. Let's see. I think the rest of these are just configuration type things. So let's go ahead and create the arrays for our point lights. So this is going to be darray create, but it's going to be point light simple scene config. right? And I'm actually just going to copy pasta that and change this to meshes. And that's going to be mesh simple scene config. I probably should have named that simple scene mesh config, simple scene point light config. Those are a bit backwards now that I think about it. I might rename those. Anyway, and then we should probably also go ahead and we're allocating space for this, but we need to k0 memory resource data, and then size of simple scene config, right? Let's just zero that out just to make sure. Kallocate should be doing that for us, but let's go ahead and be line 25 still references the other loader. Yep, you're right, it does. Good catch. I'm probably going to do a search for the word shader on this file before I tie it up, just to be sure. Okay, so that covers what we need for now. So now we have reading each line of the file. We'll come back to that in a minute because there's a lot of stuff in there that we're going to have to change and remove. So really I only want to keep like an example or two out of this and delete the rest of it because there's a lot of stuff there we don't need. The unload is basically just going to undo the top thing. So I'm going to have simple scene loader unload. Go ahead and accept that. This is going to be simple scene config. So clean up split array, string split array. I don't know. I don't think we're actually going to have any of those. So we don't need either one of those. We are going to destroy the data meshes and the data point lights. And then we can go ahead and free the data name, because either way that's going to be dynamically allocated. So the size of that is going to be string length data name +1 mem tag string. Okay, we should probably also check if data name. I can't think of any reason why that wouldn't exist, but let's just make sure it does. I suppose we could be pedantic here and say if data meshes, right? Just for some reason in case, oops, in case it doesn't exist. And then we'll do the same thing down here. Point lights, right? So we'll get rid of those. We can also do this for description. You know what, description, I'm not going to default that to an empty string. I'm going to default that to 0. That way I don't have to worry about trying to detect whether or not it was constant data or not. Redstone, thank you so much for the follow. I appreciate it. All right, so I'm going to turn off my Discord because for some reason, even though that I have streaming mode enabled, it still keeps bleating at me in the background. Okay. Hey, how are you? What's your favorite engine? So if you mean like pre-built engines, I think Unreal is pretty cool. However, it's very large and very heavy. So it's great for huge projects and, big games like that. But for things that need to be lightweight and simple, it's a little heavy. And that's one of the reasons I'm building this one. So I think more or less, like, I can't really say this is my favorite engine just yet because it's not really usable as a game engine just yet, right? It's a little too soon to say that, but my goal is eventually to have this be my favorite engine. But yeah, for now, if I had to answer that question, I'd probably say Unreal. So for most indie devs, it's too much. I wouldn't necessarily say that. I would say it's project specific. It depends on what kind of game you're making. Heavily depends on that. There may be better options depending on the game. Okay, so we are at description. So if we have description, we go ahead and free that. All right, so we don't have attributes here to destroy. We don't have uniforms here to destroy. What else is there? We should probably iterate these objects and like clean up strings and stuff like that. But for right now, I'm not going to worry about it. I'll come back and do that once I know exactly what those types are all going to use. Okay, so let's do this. And then we'll call resource unload. We will change this. All right. Cool. So that is our unload function. And then our simple scene resource loader create. We have a loader. We have a resource type, which I don't think we have a resource type for that, so I'll have to come back to that. Our load is the simple scene loader load. Our loader unload is the simple scene loader unload. And then the loader type path, we're going to change this to, I think I put this in scenes, didn't I? Yeah, scenes. Right, so that'll be sort of the default path where that sits. What about Unity? Unity, I think Unity is a little bit overplayed, to be honest. I think it has its uses, but it's kind of a mess, I feel like, right? And I feel like a lot of people are saying the same thing lately. I know with every new version, it seems to be getting more and more buggy. Godot, I've not actually used Godot. I do like some of the concepts behind it. I've read up on it a little bit. I do like some of the concepts that they have behind that, but GameMaker is pretty awesome, I'll say. Yeah, GameMaker is quite awesome, especially if you're making a like a 2D game, like a side scroller or an RPG, something like that. GameMaker is really awesome. It's really powerful. It's relatively lightweight. Yeah, it's a pretty good engine. Don't like the price part of GameMaker. I mean, yeah, that's a thing. I mean, that's the thing with all engines, right? Unless you're using an open source one. Because even though a lot of those engines are free, right? They're free up to a certain point, and then you got to pay a certain percentage in royalties. So, the open source ones can be pretty good to use, but the non-open source ones can get kind of expensive depending on what you're doing. Again, depends on the project. Depends on how much you expect to actually make, or how many people you actually expect will download your game and buy it. All right, so that's the loader, at least kind of configured. So what I'm going to do is come through here and get rid of the things that I know beyond a shadow of a doubt we're not going to use. So attribute is one of those things because it has all this type stuff that it parses out. And then uniforms is another one of those things. So we're going to go ahead and get rid of uniforms. I have to do more fields here. I don't know if I'm going to need that or not. Let's see. Stages is another thing I'm going to get rid of, as well as stage files, actually. So we've got that. All right. And now we just have some really simple things to sort of use as an example. So the way that this loader works is, whoops, what do we got going on here? Looks like an extra character made it in there somehow. So the way that this works is this reads each line of the file. So it reads it line by line, and we process each one of those lines at a time. You agree with most of the things I said except GameMaker? I mean, yeah, GameMaker, yeah, it can be expensive, but I think it's good for like 2D projects. You know, there are different alternatives. Again, it's all in what you're building, right? How is my engine going? My engine is going well. I am the only one developing it, and I only develop it on either YouTube videos or, until recently, streams. So it's coming along pretty decently. We've actually been at this 2 years, but like I said, all development, with the exception of occasional bug fixes and stuff I do offline, all development is actually online. So that means it takes a lot longer to make it and get it going, but you know, it's coming along pretty good. We have a basic renderer set up, and we're getting to the point now where we're going to be starting to add features somewhat rapidly, I think. The name of it is the Kohi game engine. So if you want to know more about it, you can actually go to kohiengine.com. And let me just, whoops, wow, really? I closed the tab instead of dragged it. Okay. So you can go to kohiengine.com. And there's a lot more information about the engine here. It does say that it was built entirely on a YouTube video series. That is how it started. Yeah, ooh.com. Yeah, I know, special, right? Snazzy. So it did start off as a YouTube-only series, and then I switched to streaming. So all of the streams that I do are archived on the YouTube channel, so you can follow it there. It's a lot of text, yes. But it does give sort of an idea of the project, right? So the idea of this is to learn how engines work and sort of set the scope and expectations of what we're doing. It gives links to like our Discord. You can find the source on GitHub, support on Patreon. All those different links are here. We also do have API documentation. So if you were to click this guy, you can actually look up like the documentation for, you know, our D array, for example, is all here. So we do have documentation that's auto-generated whenever I push to the repository. So there's that. Let's see. And then there's also a forum, which is not widely used yet, because I just kind of set it up silently and never really talked about it, but there is a forum that exists as well. What renderer? So it uses Vulkan as its rendering backend, but this is designed to be it's designed to be agnostic of what type of renderer it uses. So the way that this works is the renderer is actually a plugin. So in this case, we have a Vulkan plugin. So we see here that we have this Vulkan renderer. This is a DLL, at least in Windows, it's a DLL. And the Vulkan renderer exists as its own thing. Eventually, if we want to write one that's for OpenGL, DirectX, Metal, whatever, we could just write a plugin for that, register it with the engine, and bam, it'll just work. So as long as we implement the interfaces, you know, it'll work. Can you be a tester one day? Absolutely. I mean, you can download it now and build it and play around with it if you want, for sure. You know, it's you have to download it and build it right now. I don't release binaries yet. We're not far enough along for that. But eventually, yeah, you'll be able to download it like you would any other engine. You'll be able to download an installer / executable, whatever. But yeah, absolutely. We're definitely going to need testers, right? right now I'm basically the only tester, aside from the folks that sort of follow this project and build it on their own and kind of realize issues that come up and stuff like that. So how big will it be in megabytes? I'm not sure what you mean. Like when we go to package the engine. Cookies, thank you so much for the follow. Appreciate it. So in terms of that, I mean, it's really hard to say, right? I think, let's look at the bin directory now, because I actually have not looked at this at all. So I actually don't know. So if I do, like, the engine DLL is what, 1.4 megs, right? Some of these other things here are just debug files and stuff. So the DLL, the testbed exe, tests exe. I mean, these are all relatively small files. These PDBs are the big files. Those are debug database files, right? So those don't technically count, because if we do a release build, those won't get generated, right? So it's not very big at all. Like, our Vulkan renderer is only, let's see, that's the, yeah, so our Vulkan renderer is only 654 kilobytes, right? So, I mean, a few megs. It's smaller than Godot, yes, but it's also not near as feature complete as Godot, like nowhere near. We don't have a UI system yet at all, for example. So, you know, we're building this from the ground up, so we don't have a lot of the systems that they do. But we do have quite a lot of groundwork laid, right? Like, we built a lot of different systems in already. So we think we have things like input and event systems and platform systems, right? So right now we officially support Windows, Linux, and Mac. So those are all supported and run. And, you know, we're not using SDL or anything to do that. We have all the platform code we've written ourselves. So cool. So back on topic. So where we were at with this loader, we read the file line by line. We skip blank lines and comments, right? So if the line length is 0 or it starts with one of these guys, we skip it. We do a trim on the line as well. So, like, if we have this, that still counts as a comment, right? Because we're doing a trim. Let's see. So the next thing we do is at least for right now, this is splitting every line into var value, right? Because this is what the shader loader did. So we're going to want to conditionally do this, because we're not going to want to do that for anything that begins with an open bracket or an exclamation point. Everything else, though, I think we can. So we'll need to put a condition there. So I guess the first thing is if trimmed 0 equals open bracket, else if trimmed 0 equals exclamation point, right? Because that's for the version. And then we have else. Oops, I forgot the parentheses. Okay, so the else here is going to wrap. I guess we're going to do the split here. Let's see. So we do the split. We have the raw variable name, the trimmed variable name. So we do the trimming of the variable name and the value, right? So we need that and this else. And then we process the variable. So let's go ahead and wrap to here, right? And then we're going to actually take this version here. We're going to snip that out of here and turn this into the first else, right? And we're going to put the version here, right? So the trimmed variable name, we actually, we do need that to actually split too. So actually, I'm going to undo that change and get rid of this clause, right? Instead of version, this just needs to be exclamation point version, right? And then what we can do is we have various things like string to bool or string to int, which is what we're going to use. So we'll say string to, let's do this as, I guess we could do an I32, I think it was. And we can say resource data. Wow, resource data. I thought we had version on here. Oh, right. We don't need to store this in the resource data. We actually need to store this up here because the resource data doesn't actually know or care about it. The only thing that cares about the version is the parser. So actually I'm going to say U32 version. And I'm going to set that to 0 by default. And that just means that it hasn't been initialized, right? So it should be at least 1. And that will be how we can tell whether or not we have loaded the version or not. So I'm going to say to U32. And we're going to pass in here trimmed value. And I believe this outputs a U32. So I'll take the address of version. Okay. And then, of course, if that fails for some reason, then we'll go ahead and bleat about it. And interesting, we're not actually checking a lot of this stuff, which is probably not good. So I'll say k error invalid value for version. And then we're also going to write that out as a string. So %s, and we'll say trimmed value. And at this point, do we have anything? Like, that's really the only thing that can really completely just go wrong, right? So I'm going to return false. And I'm going to put a to-do here. Clean up config, right? Because there are some allocations that were made before this, right? Okay, so we process the version, and then we can individually check for each one of these things that we process whether or not the version has been set. And if it has not been set, then we throw an error. Let's see. Can I show you my project, just the itch page? I would rather you not link it here, but if you want, feel free to go over to our Discord server and drop it there, because it'll just get lost in the chat here. All right. So the first thing that we're going to have to look at is we may have to split this up a bit, actually. Because we're technically going to be entering into like a parse mode for each one of these things. And each one of those things has different variables that it takes. And I really don't want it to be a huge thing like this, right? We should probably split that up into like individual functions that handle that kind of stuff. Okay. So if we if we have an open bracket, then that means that we're entering into a mode. So if, I guess I could do a string. Do I want to do if string equal I? Let's do case insensitive. So we'll say trimmed. If trimmed is equal to seen, right? Then we'll go ahead and, what am I doing? Surround this in the if, you dingus. Okay, so if strings equal I is equal to seen, then we will enter, actually, parse seen tag. But then I've got to figure out how to make this advance if I do that. You just made me 4 cents. Was that the because of ads or something? Let's see. How do I want to do this? I guess I could just set a mode and just enter that mode within this loop. And then within each mode, I can have a switch, and then it will have the values that I can look for. Yeah, that'll work. Okay. So I'm going to need to define an enumeration up here. Overcrush, thank you so much for the follow. I appreciate it. So type def enum. Let's call this simple scene parse mode. And we're going to have a few things here, basically a mode for each one of these things. So I'll say simple scene parse mode. Yeah, that's fine. Scene. Right, and then we have, we'll go with skybox. We'll go with directional light. We'll go with point light. Mesh. And I think that's it, actually. Discord, I thought I killed you. I hate that when I click close on Discord, it doesn't actually quit. Anyway. So, it's on the Discord. Cool. I will check that out after the stream. All right. So we have the simple scene parse mode. We also should have a mode that I'm going to call root. Oops, root. Wow, if I can type root. There we go. Okay, so root mode is basically going to be the default mode that we enter into, right? It's going to be when we're processing like this stuff up here, right? And then whenever we enter one of these tags, we'll enter a mode there. And then when we close this tag, we'll go back into root mode. And that is how we are going to do this. So I guess I'll go here and I will set that here. Mode, I'm just going to call it mode equals root. All right. I suppose we could have some sort of checking too, to make sure that we're, not trying to load something like this, right? Because that doesn't make sense. So we should probably also treat this a little bit like a state machine. You have a project where you have to write a 5,000 word constitution. Ouch. That sounds painful. Good luck with that. Okay, so if the string is equal to scene, then we'll set the mode equal to scene mode scene, right? We probably should also do our check, right? So if mode equals simple scene root, parse mode root, rather. So if we are equal to that, then we'll go ahead and do this. Otherwise, we are going to k-error error loading simple scene format error unexpected token scene. Cool. We're also going to return false. All right. So if we get something like this, that means the file format is just bad and we shouldn't process it. Cookies. Hi, I'm glad to see you're still working on the Kohi game engine. Yes, I am. Believe it or not, we actually just passed the 2-year mark with this. So that's pretty cool. I didn't even realize it. Actually, somebody on the stream brought it up, that it had been 2 years. That was a few weeks ago. Okay, so now we're in this mode. So I suppose we ought to just kind of set up all of our modes here, right? So let's go with an else. And instead of scene, we'll do skybox. And we need to be in root for that. Set skybox here. And then unexpected token skybox here. It's basically going to be the same thing. We could probably simplify this or offload it to a function, but for now I'm just going to keep it online. Directional light. Copy that here. Change that to directional light. And then point light. Copy that there. Change this to point light. And then I think mesh is the only other thing that we have. So we'll do an else if for mesh. Notice I'm not doing an else here because we also want to catch the unexpected types here, right? So the other thing I'm going to do is else. And then if it's not a recognized type, I'm going to say k-error, error loading simple scene file format error unexpected object type, and we'll spit that out as a string in single quotes, and we'll say trimmed. Turn false. All right, so now we have our mode switching in place. This is my 3rd game engine? No, this is like... God, I don't even know how many I've written at this point. Well, I guess you could say professionally speaking, this is my 3rd. Although the ones I've done sort of on my own, like research-wise, that's in the dozens for sure. Yeah, I don't even know how many how many there are, but yeah, it's been a lot. I've written OpenGL engines and DirectX engines. I've kind of written a couple of basic Vulkan engines just playing around, but none of them got as far as this one. So yeah, I've written lots of different stuff. Actually, no, this would be my 4th that I'd count as professional, because I kind of started that TypeScript engine that's on the channel as well. Although that's not anywhere near complete. But we did use it to make a small, simple game. So eventually probably am going to circle back to that at some point. But this one is just way more interesting for now. All right. So... change modes. So now that we have all the switches into those various modes, we actually need to have the switches out of those various modes as well, because we have these closing tags. So we have all of them to transition to that. We don't have them to transition out of it. So I'm probably going to place an else if for each one of those as well. So I'm going to do scene here, but it's going to be /scene to match this, right? So this will be /scene. And then this has to be in scene mode first, and then transition to root, right? So it kind of does the opposite of this. So it must be in scene mode when you hit this, and then it has to, then it changes you to root, right? So I'll need to add one of those per, and this is, I was going to do all this in line, but this is really kind of gross, right? Yeah, I don't really want to do that. I am going to, I'm going to split this out into a function. Guess I can put it up here towards the top. Nah, I'll declare it at the bottom and forward declare it at the top. Ozyrix, hello, I'm building an engine as well. It's funny because I also have a good number of prototypes I've worked on before having something stable today. I've built 2 WebGL research projects and 3 in C++. The current one is also in C++. Nice, that's awesome. Yeah, I actually, I used to have a lot of those things public on my GitHub, but they were like all unfinished projects, which I kind of thought was bad, so I took them all down. But yeah, I totally understand having the unfinished projects, right? Definitely have a fair number of those. So I'm going to declare this as static. The return type is going to be B8. To indicate success or failure. Yeah, okay. And then try change mode. And I'm just going to paste this in here for right now. So the const char, the first one, I'm just going to call this value, right? And I'm going to change trimmed to value. And then I'm going to take in 2 of these modes, which is just going to be expected, current, and then target. And then if this returns true, then we'll go ahead and change the mode. So maybe we'll say can change mode instead of try, right? Because this doesn't actually change the mode. So here we're going to and actually this string's equal. This doesn't actually even belong in here. This actually does belong up here. Yeah, that's there. Okay. So really the only thing we're doing is return mode equals expected. Oh, right. We shouldn't be setting the target here. We should be setting the current. So current versus expected current. Maybe we should flip those around. I don't consider it as unfinished since it wasn't the goal to finish it, but having a project to experiment, design, explore new features to learn, that's totally fair. I call those test beds myself, which is kind of where the test bed functionality comes from here. I also noticed that designed a game engine is not a trivial task because all parts and concepts it involves, hence the time needed to design and plan all this stuff. Absolutely, yeah. And it's very volatile. It changes as you go along, right? It changes a lot as you go along. So generally speaking, the first design of your engine or the way that you envision it when you start the project is totally not how it comes out in the end. And that's okay. It's just, that is how it is, right? So here, I'm going to say if current is not equal to expected current, then unexpected value, right? And then we just return that. So this just kind of wraps that up nicely for us. So now I'll just go to the top, put a declaration at the top so they can then come down here. And within this, all I have to do now is if can change mode, trimmed, mode is current, and expected current is root, right? Then we'll set the mode. And the error logging is already done for us. So the only other thing I have to do is return false. That's a little bit cleaner anyways. I guess I could also go in here and actually change. Yeah, I'm going to rename this back to try change mode. So I'd like to encapsulate a little bit more of that logic. Right? And I'm actually going to take a pointer, and I'm going to call this out mode. And that means my other definition at the bottom will need it. Right. So we can say else. What did I call that? Out mode equals. Oh, I don't take in the target. Right, but I could just make that the pointer, right? And then change this to be not a pointer, but a target. That makes more sense. So current is going to be the pointer. And then this will be target. Right? And then all I have to do is set target equal to current rather equal to target. Otherwise, we don't change it at all. Okay, so that actually does the try change mode. Okay, so that means we need to go back up here. We're going to pass the address of mode because we need a pointer to that. And the target is seen. All right, and then we'll change this to a negative case and return false if that fails, and then we can get rid of this. That is a lot more concise, I think. Right, let's get rid of that folder view. Okay, so yeah, this is a lot better than this, I think. Okay, so basically we're just going to convert these real quick to that. So the mode, the expected is seen now, and the target is root. So we can get rid of that. So the expected is root, and the target is skybox. Yeah, let's just convert all these, and then I'll add the other ones in there. So that way these are relatively the same, right? So we'll get rid of that. Do this for point light. And one more time for mesh. Get rid of that. All right, cool. So now we just need to do the other closing ones. So we have the one here for scene. That I'm actually just going to copy and put right below skybox. So this is going to be closing the skybox, and then we should be in skybox mode and transitioning to root. I'll copy this, and we'll do the same for directional light. So we'll change that to directional light, this to directional light, and that's it. Then do the same thing for point light. This should be point light. And finally, oh, did I forget the close bracket there? I did. Finally, we'll do this for mesh. And there we go. So now we have the transition into and out of for all these various things. And I think these are all correct. I guess in retrospect, I probably could have used the lookup table for this, but whatever. That's all the refactoring I'm going to do. I want to move on. Okay, so that's all the mode changes. So now when we're processing variables, here's all the split logic. We need to keep that global. And here is where we actually we actually need to do one thing before we do any of these changing modes. Remember I said we need to check the version first, and this could be because the parsing of these things could change. So before we actually get to any of that, we should come across the version first. So if version equals 0, k error, error loading simple scene file version was not set before attempting to change modes. Okay, so that covers that. And then we don't have to check that stuff every time in here, because the only time that that's going to matter is when we're actually changing modes, right? Because you have to change modes to actually set properties. Okay, so version we can keep global, right? So the version should only ever occur. So we probably should do a quick check here to say if mode is not equal to simple scene parse mode root, then k error attempting to set version inside of non-root mode, we'll say. Turn false. Okay. Right. So that is that. We really need to do up some cleanup to the config with all these return falses. That's going to be an issue eventually. Okay. So the next thing we want to do is name, and we don't want to just set resource data name, right? Because resource data name in fact, this is not even the name of the, well, yeah, it is. Okay, so if we set the name, then we want to override that. If we're in root. No, if we're in scene mode. So every one of these has a name. So I think it's safe to say, we'll do a switch statement here on, on the mode, and that'll tell us where to actually apply the name. So in this case, we will say, I guess let's go with, we'll go with this one first. Case break, right? And then we'll move this up here. Parsing a name in a root node probably shouldn't be possible. So let's say case simple root return false, right? We're going to throw an error here. All right, we have an ad break coming, so I will be right back. So for those of you guys that are subbed and not having to listen to ads right now, how are you guys doing tonight? If you guys are still watching. I don't mind having sort of off-topic conversations while ads are running. If I actually happen to catch the fact that ads are running. Good, got a nice new desk recently. Sweet. Love it. What kind of desk did you get? Like a standing desk or something, or? You're not subbed but not having ads. Nice. Yeah, I just try to sort of pay attention as the stream is running to like when the ads manager actually pops. I don't always notice it, but anytime I do notice it, I try to sort of stop the stream while that's running. It's an uplift desk, so I have buttons raised. It's a game changer. It's funny you mentioned you have an uplift desk. I actually have an uplift desk as well. I have one. My wife has one. A couple of my friends have them. They're amazing. Yeah, and they totally are a game changer. I was actually considering doing the standing position tonight, but I just didn't feel like it. But yeah, I love mine. Yeah, they really are amazing desks. They're really well built too. They're high quality. I'm not even like sponsored by them or anything. It's just I've bought several of them and assembled several of them at this point over the years. Cool. All right. So ads are done. So if we are in root mode and we're trying to process a name, we probably shouldn't be. Cannot process name in root node. However, I'm going to make this a warning, right? Format error, warning, right? Because names aren't really something that that have to be there unless you're trying to link objects. So I think I'm just going to have this one throw a warning and just keep moving. Okay, so if we're in parse mode scene, then we should have a current scene, which we don't. That's something that we actually need to do when we change modes. Well, actually, we do have an active scene. The active scene is the resource data. So actually, that's not 100% true yet. It will be for meshes and point lights, because we can have multiples of those. So we're going to have to handle those a little bit differently. But for the scene, that's fine. Case, simple, scene, parse, mode. Let's do the simple ones first. So we have directional light. We'll do first. So resource data, directional light config dot name is equal to string duplicate, trimmed value, break. It's also going to be the same thing for skybox mode, because there's only one of those per scene, so we can just set it directly. So skybox, right? Skybox config, and that has a name. Okay, so the last two are going to be a little bit different. So I'm currently in hammock below my uplift desk. You know, I heard you can get those. I don't know, with all the crap I have on my desk though, I feel like it'd be too much weight, but I don't know, maybe not. That, and I'm not exactly a light guy. But I've heard of people getting those. It's kind of awesome. So we should probably have a concept of a current point light and a current mesh, because we can have multiples of these things. So when we switch into the mode, we should probably go ahead and create a current one of these configurations. And then when we switch out of the mode, we should push it into the list. That is what makes the most sense to me. So I think what I'll do is I will create a couple of them up here, rather. So I'll say simple scene point. Whoops. What did I call it? Point light simple scene config. Yeah, see, that's backwards. I probably should rename that, but current point light config, and I'm going to zero that out. And then I'm going to do the same thing for mesh. Mesh simple scene config. current mesh config. And I'm going to 0 that out, right? And we'll sort of use these kind of as like buffer objects. So buffer objects that get populated when switching, when in corresponding mode, and pushed to list when leaving said mode. Just so it's, when I look at this in 6 months and go to update it, I understand how it works. All right, so when we switch to, let's do the point light one first. So if the change to the mode is successful, then what we want to do is k0 memory, current point light config, right? That way we're starting with a brand new configuration. We don't have to worry about anything being set, right? And this is, of course, point light simple scene config. So size of point light simple scene config, right? So we'll go ahead and 0 that out. Oh, I need the address of that. I was like, why isn't that working? Duh, it's not a pointer. All right. And we'll do the same thing for mesh, right? So when we enter the mesh mode, this is going to be current mesh config, and then mesh simple scene config, right? And then when we switch out of these modes, and we do it successfully, right? Then we're going to say darray push. We're going to want, the array is going to be resource data. And in this case, it's going to be point lights. And then we want to push, I'm going to go ahead and push current point light config, right? All right, that should work. And then we'll do the same thing here when we leave mesh, except it'll be meshes and current mesh config, right? So that should work. I guess we could 0 the memory out again, but I really don't see the need to do that if when we change into the mode, we're 0ing it. So I'm not going to do that. All right, so now that we have our current configs, now we can actually finish up the modes for name. So in this case, we're going to do parse mode. Let's do point light. And this is going to be current point light config dot name. Right, so we'll go ahead and do that. Ooh, that's going to leak memory. We better take care of that now. So when we go to yeah, okay. I wasn't going to do this, but I think I'm going to. So when we push this, we also need to destroy it, right? And then 0 its memory out. So if current point light config dot, I think name is the only one that's dynamically allocated. Yeah. So if we have that, then we will k-free the name, string length, the name +1, and then mem tag string. All right, and then we 0 the memory. So let's just say push into the array, then clean up. All right, and so that is also going to need to happen on mesh. So I'm actually going to copy this comment as well. So current mesh config name. Okay, and then I think current mesh also has a couple things. So parent name and resource name also. So let's go with resource name next. And I'm just going to copy pasta this. Resource name, and parent name, and then we do the current mesh config, mesh simple scene config. Right. We would otherwise leak all of that memory, which would be terrible. Okay, so so that's handled automatically for us now. All right. So the name handles all these cases. And I think there's a couple of other ones. I think position and color are going to be some common ones. Well, this has direction, but color is here. Spelled differently, though. Should probably keep that consistent. Okay, so I guess I'm going to do the same thing here. So I'm going to take this one and change it to color. Take that one over, and then I'm going to do a switch on the mode. Oh, that reminds me. I'm going to default this to the root. Same here. So color is only used by directional light and point light. So I guess I could just copy over the warning, right? So if we're in scene, we'll say scene mode. I don't know if I want to do that for every single variable though. In the current mode. Right, so we'll just delete scene. We'll delete skybox. So these are the only two that take it, right? And in fact, I'm just going to say default, right? I suppose I could try to spit out what the name of the mode, but I feel like you could figure that out just by looking at the file. Okay, so that's color. Position, I think, is only used by directional lights. So let's do some other ones. Like we have description. So I guess we could do, I'll take description here. And then if mode equals scene, right? So if mode is equal to scene, then we'll go ahead and do resource data description equals string duplicate trim to value. Right? Else cannot process description in the current mode. Right? So that's description. So we have scene covered. Skybox, we have cube map name. So I suppose that's the next one we can do. So we'll do cube map name, and this is basically going to be a copy of this. So we'll just go ahead and paste that in here. So if this is skybox mode, then skybox config cube map name. Right? String duplicate. And then otherwise just warn. Okay, so that takes care of skybox. Directional light, we have name and color already taken care of. So direction is going to be the next thing. And I think this is the only thing that takes direction. So we can just say direction. And I'm going to copy this again. And this has to be a directional light. We'll say directional light config. Direction, except we're not parsing a string in this case. Well, I mean we are, right? But we actually have to parse this. Whoops, we have to parse this as a vector 4, which actually it looks like I missed some more f's. So let me get rid of those, because those are not going to parse. I don't think I missed any more, though. I think that's all of them. All right. So obviously direction is a vector 4, so we can say vec 4. Do we not have? Is it a string function? To vec, yeah, it's a string function. String to vector 4. Oh, and we out vector this. Okay, so let's move this here. Right. The first argument is the string, which is going to be trimmed value. Whoops. Editor, what are you doing? Okay. Right. And then the out vector is going to be the address of directional light config.direction. Right. And then we need to negative check this to say if wasn't able to do the thing, then kwarn error parsing directional light direction as vector as vec4. And I think maybe what we'll do is we'll just use a default instead, which actually I'm going to take this value in here and use that as the default. So we'll say resource data dot directional light config dot direction equals, put these in here, add back the f's with commas, right, and then cast that to a vector 4. Using default value. So at least that way, if we provide rubbish, like we don't have to abort the engine actually running or the light getting added at all, we can just simply say, hey, use a default instead. Because we want to try to avoid aborting whenever we can. Okay, Oh, I missed a couple of warnings here. So this is description. This should be cube map name. This should be direction. All right. Okay, so that's that. We already have name. So okay, so that's done for directional lights. We have name, resource name. So resource name, I think I'm going to put here actually, because it's kind of next to this other name, right? So I'm going to say resource name. And then this has to be, right now, I think the only thing that uses this is a mesh. Yes. So this has to be in mesh mode. And then this is actually going to be a string duplicate. So it's going to be resource data. Actually, no, it's going to be current mesh config.name. Resource name, rather. Right? And then while we're at it, why don't we just knock out the parent as well? So we'll say parent. That's also only valid in mesh mode for right now. So we'll say parent name. Whoops, parent is in caps. Why? Caps lock, why you on? All right. So parent names, string duplicate, trim to value. Perfect. Okay. So the only other thing is transform. My dog just had a really loud sneeze. Don't know if you guys heard that. Okay, so that's going to be something similar to this. So we're going to have transform. This has to be parse mode mesh. So that's meshes are the only thing right now that has a transform. Do we have string to transform? No, I didn't think we did. Okay, so we're going to actually have to write that. So I don't think we have even transform included here. So we're actually going to have to create a transform from a string. And we're going to do it a similar way to how we did it for vector 4, right? So if I recall, scanf I think tells how many elements were parsed. Return value. The number of items in the argument list successfully filled. Okay, so we're going to need to know that when we go to handle this. So I'm going to copy this guy. Where do I want to add this? Well, you know what? I'm going to stick it up here with the other similarly processed things. I need transform out transform. Let me go ahead and declare this in the kstring.h file. So string 2 vec4, put it right above here, right? I'm going to export that. Attempts to parse a vector, nope, a transform from the provided string. If the string only, we'll say if the string contains, let's see, what is this? 1, 2, 3. So if it contains 10 elements, rotation is parsed as quaternion. If it contains 9 elements, rotation is parsed as Euler angles and is converted to quaternion. Anything else is invalid. Okay. So this is going to be the string to parse from. Fix that. A pointer to the transform to write to. All right. And then true if parsed successfully, otherwise false. Cool. Whoops, we need a, all right. So, that is that. Obviously, if we don't have a string, or we don't have, or we don't have out transform, that's a return false. Which these aren't actually checking that either, so that's a bug. So let me just put that in here for these guys. Wow, none of these have it. Okay. And when you find stuff like this, you gotta stop and fix it. So yeah, none of these had it. Change that to you. You, and you. Not B. Okay. There we go. Fix that. That would have been a crash otherwise. Okay. So we sanity check for both of those things. We zero memory, the out transform, size of a transform. Now instead of parsing these things directly to the transform, we can do that with the position, but it's going to switch after so we probably ought to do it with a, I'm thinking an array of floats. It's probably going to be the way to do it. So we want to have potentially 10 of these, right? So that's 5, and then I'm just going to just copy this to 10. Oops, minus the quote. All right, and then I'm going to do F32 floats, values 10, and I'm going to set them all to 0. Right. I'm going to call result count, right? Because we're actually going to need to examine that. And then for each one of these, we're going to have to do values and then sub-0 values. I guess I don't have to do this position, right? So let's make this 7, right? Because we can assign position directly. That's always going to be the same. So let's do that. Transform, out transform rather, position.x. This is definitely going to have to be a multi-liner. So let's just go ahead and do that now. Then we need y. And then we need Z. Okay. So we can do that. But then we'll start filling in this guy. So we'll say values 0, 1, 2, 3, 4. Whoops. 4, 5, 6. Right? Okay, so if count equals 10, then we can just load these directly. Treat as quat load directly. Okay, so it's literally going to be transform out transform rather rotation, right, which is already a quaternion, dot x equals values 0. I suppose I could do an element set with a loop, but it's not going to be less lines of code. So I'll just do it this way. 2, 3, W. All right. And then we're also going to set scale. And the reason that we're doing scale here as well is because the index of that could be different depending on how many elements of rotation we have. So in this case, we're going to have out transform scale.x equals values 4. All right, and I'm just going to copy pasta this again, 5 and 6 for y and z. Right? Else, if count equals 9, then we're going to have to do some conversion, right? Because we're dealing with Euler angles. So, don't I have... I don't have kmath included. So include math kmath. All right, so we only have mat4 conversions. Well, technically speaking, if these are, I believe if they're Euler angles, I think you can just assign them to the properties after converting them to radians, right? Because if they're Euler angles, you're going to assume that it's degrees. So we'll do deg to rad values 0, and we'll say out transform rotation.x equals that, and then 1, 2, or 0, 1, and 2, y and z, and then we'll set the w component to 1.0. Not 100% sure that that's right. I need to validate that. I don't recall off the top of my head. It's been a while since I've had to do that. Let's see. Yeah, it's not quite that simple. I didn't think so. So because the thing you have to consider is that it can gimbal lock as well. So this isn't going to like avoid that, because if you're starting with Euler angles, you're risking gimbal lock to begin with. Is it axis angle? Oh, I think the way to do it is going to be oh, right. Okay. So I need to take the axis, which is going to be back 3. Yeah. So we want the x-axis first. So that's going to be 1.0, 0, 0, and then the angle is going to be this. Right? Quat x rot equals that. Normalize. We'll say true. We do want to normalize that, right? So I'll do one of these for each axis. I'm still not 100% sure that's right, but it feels a lot better than just plugging them in, right? And this is going to be 1.0 f. Whoops, not g, f. I'm sure somebody in the comments is going to correct me on this. And that's fine. Because I think what you're supposed to do is quat multiply x rotation, y rotation. And this actually is going to be a quat multiply y and z. What is it? Y, z rot. And then we can say out transform rotation equals that. Right? Because the way you combine quaternions is you multiply them. So it makes sense if we do the axis angle from each of the axes, convert degrees to radians on each one of those values, multiply them together, and we should have the rotation that we need. Right? Else, we are going to k-warn invalid, actually we'll say format error invalid transform provided. Identity transform will be used. So in this case, we'll say out transform equals transform create. Do we not have transform h? We do not. Include math transform h transform create. There we go. Okay. Oh. We'll just set the whole transform. I suppose we could return false there too, but Yeah, I think I am going to return false. Because that's technically an error, right? Otherwise, we're going to return true. Cool. Do any of you guys have questions so far on any of this stuff we're doing? Just let me know. Did I just do this in the wrong? Oh. String to transform. Did I do that here? Yeah. I didn't rename it there. Okay. All right. So now we have a string to transform. So all of that, so that we can come in here and say string to transform. And then this is going to be the current mesh dot transform. We want the address of that. If we don't do that, then we're going to say error parsing mesh transform using default value, and that still applies. We just don't have to do it there, right? This kind of automatically happens in here. Okay. Change that to transform. Okay, so we have our transform figured out, and it accepts both types of rotations, which is pretty cool. So we have name, resource name, transform, parent. Those are done. That's the mesh. The point light, the name is done. Color is done. Did we do position? I don't think we did. No. So position, I'm going to basically take a copy of direction because it's the same logic. But instead, it's a mesh, right? So where it gets applied is different. Sorry, it's not a mesh. It's a point light. So where it gets applied is different. So we need the current point light config position. And if that fails, then we're going to say point light direction as vec4 using default value. And for this position, we are going to just use vector 40. Vec4 0. Oh, and that is oops. Position. Okay. The rest of these are easy, thankfully, because they are just floats, and I think this is the last 3 fields that we have to worry about. So those are going to go pretty quick. So we just need a few more cases down here. So if the name is constant, wow. If I can spell constant. Wait a minute. I didn't update this error message. That should be position. Okay. Transform. Okay. Constant. Actually, this is string to float. Whoops. F32. Error parsing point light constant. So this needs to be point light. This needs to be current point light config constant using default value. So if we run into that, the constant is going to default to 1.0f, which it is in here anyway, which is fine. Suppose we ought to come up with some way to provide some defaults, right? That might be a good thing to do at some point. All right, but let's move on for now. So I think this is looking pretty good. So that is constant. We need another one for linear. And I'm just kind of taking these values as the defaults, right? So put that here. Linear, point light linear, 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 right? Okay. So that's that one. And then the next one is also going to be just as simple. So it's going to be quadratic. So basically just replace that. And then the quadratic here, default, we're going to use 0.44. All right. Okay. Otherwise, we're basically going to ignore it. So I believe this is our entire configuration setup. We've replaced all of our logic with the parsing logic of this, complete with modes. We have some basic error checking. We got a couple other things here. So we have simple scene config for the data size. Okay, we already cleaned this up. We are going to have to do some other stuff here, though. So let's see. Okay, so if we have meshes and point lights, we're actually going to have to iterate that and destroy those, right? So darray u32 length equals darray length data meshes for u32 I equals 0, I is less than length plus plus I. If data meshes sub I dot name, then we are going to k-free that, and then we're going to do string length of that plus 1, and then mem tag string, right? Okay, so that's the name, and I know for this one it's got a couple of things in here. So we have parent name, so we'll do parent name for all of this, and then there's another one too, I think, resource name. So we got resource name. Okay, so now that is good. So data meshes is cleaned up. Point lights, we're going to have a name. So we're going to have to iterate that as well. I'm going to copy everything up here to name. Change this from meshes to point lights. That's the only thing that point lights actually have. Yep, okay. The only dynamically allocated thing, I should say. Okay, so we also need to take a look at if data directional light config dot name, then you know what, I'm gonna just copy this and replace with this. So we'll just do that and that. Directional light only has that. So we've done point lights, directional light, and meshes. The only other thing is skybox and scene. So we have skybox config. And then we have the data itself, the name. Oh, the skybox also has the cube map name. So we need to clean that up. Scene has description. So we're already getting that. Okay, I think that's everything. Cool. All right, so I believe, let me just do a quick look for the word shader. Aha. There was one thing I was missing. So we have resource type shader. We do not have a resource type in here yet for what we need. So we need a new one. We're going to call this resource type simple scene. Simple scene resource type. Okay. So I'll copy that, go back, paste. Now shader has no results. Okay, so we've rewritten this entire thing. I think this is good. We'll have to test it, but in order to do so, I need to register it with the loader. Register its loader rather with the resource loader. So I think it was under resource system. We have our known resource loaders up here. So include resources loaders, simple scene loader. And then we just come down here and simple scene resource loader create. And I believe that's all we need to do. Is just register the loader and it should just work. So to test this, we have I think we put that in resource types, right? Yeah. Which I need to comment those out, but I'm not going to do that on stream. I'll do that before I push this. All right, so to test this, let's go to testbed main. Do I want to do testbed main? Yeah, let's do testbed main. And I'm going to put some test code right at the top where we say load main scene, right? Because in theory, we should be able to load up the main scene from our file. And once we actually set up the processing code, we're going to replace all this code with just a call to do that, right? So we're going to get that in here first. So resource, do we not have the resource system? I guess we don't. Nope. Okay. So we'll include resources. Oh wait, it's systems. Resource system. Yeah, that makes sense. Okay. We'll go here. Load up file. Config file. Okay. So we're going to say resource simple scene resource equals source loader resource system load. We want test scene. The type, the type is resource type simple scene. Parameters, we don't have any parameters for it. And then out resource is going to be the address of simple scene resource. Right. And this, I think, yeah. So we'll check to make sure that that's successful. K error. Failed to load scene file check above logs. And I guess I can return false, right? All right. And then we'll say simple scene resource dot data, and we're going to cold cast that to simple scene. Do we not have resource? Isn't that included in resource types? Why don't we have simple scene config? Maybe IntelliSense just isn't picking it up right. Scene, oops, config equals that. Cold casted as that. Whoops, why did I put? I can tell I'm getting tired. And then just so Clang doesn't bleat, scene config. I'll just put an if check here, but I'm not actually going to do anything about it, just so it doesn't bleat about that being unused. All right, so I'm going to put a breakpoint here. Build. I wonder how many things I messed up. Oh, okay. I think, yeah, that's not too surprising because I changed current to be a pointer, so I have to dereference that. And this one is, oh, the same thing. To dereference current. What did that? One or more multiply defined symbols found. Simple scene loader load and unload is already defined in shader loader. What? Oh, really? The renamed it here too? But why though? Sometimes that rename feature just doesn't, it either catches too much or doesn't catch enough. It's not great. Okay, so we've built. And we're loading up. Here's the window. I'm going to press L. We have our resource system load. I'm just going to skip over this and see what happens. So we did get an error. I wonder why. So we didn't get any logs, right? So I'm actually just going to I'm just going to continue actually, and then step into it next time. Error loading means seen. So let's go back to the game. Load this again. This time I'll step into it. So let's see. I'm going to find the loader. I'm just going to set a breakpoint. Actually, I'm just going to go to simple scene loader and load. I'll set a breakpoint here. Okay. So the full file path is assets scenes test scene.kss. So let me just make sure we have assets scenes test underscore scene.kss. So that should be good. We opened it. Okay. All right. Let's see. We did set the mode to root, right? So that should be fine. All right. All right. So trimmed. So the first thing we hit is the version. Okay, so we split. Trim the values. Trim var name is version. Okay. So if the mode is not root, then it deletes, but the mode is root. We treat that as a U32. The trimmed value is 1, so that conversion should work. And it did. Version is now set to 1. Okay. All right. So it didn't fail there. The next thing is going to be a scene. Right, so the version is 1, so we'll skip that error. Trimmed is going to be what? Oh, scene. Yeah, so that's correct. We're going to do tried change mode. So we set the current to the target. What? So we went into simple scene. So we made the switch, but you know what? I'm just going to put a breakpoint there and load again. All right, I'm going to get rid of that breakpoint. I'll skip over that one for now. All right, so current. Oh, because we've already changed it by this time. Oh, derp. Okay. So really, this should just return false. And this should return true. I knew I was going to screw something up. Just didn't know what. All right, I'm going to trust that that's going to work, and I'm just going to skip over the whole dang thing. Let's turn off these and run. I built that, right? Okay, run. So load up scene. It did the thing. Now, I did actually kill a breakpoint that I didn't want to kill, so let me undo that. So I'll get rid of that one. I need testbed main. I do need this one. I'm going to assume that worked now, but I want to check out the config that actually loaded to make sure it looks correct. We'll check it against our file here. So we will load. We do have a scene config. Let's do this, actually. Let's resize some things here. I'm going to remove all of these because we don't need those. We're not doing that anymore. So we'll skip past this, actually, so that gets assigned. So let me move that breakpoint. And then we're going to do scene config. That way we can examine it here. Let's get rid of the call stack. So our name is test scene. Our description is a simple test scene, so that matches. We know the version's working because we saw that working in code. Our skybox config. So the name is skybox. The cube map is skybox. I should probably rename that to something a little bit different, but just to make sure that those are unique. The directional light config. So the name is, the name is wrong. How did that? Oh, that's interesting. How did that take from? All right, I'll skip past that for now. I'll come back to that in a minute. The color did not load in either. The direction actually did load in. So that's good. Okay. Point lights. Let's go to the debug console. I wonder if I can do darray length. Is that what it is? darray. darray field get. Scene config point lights. I don't know if this is going to work or not. Calling it from another module. Fully qualify the function name with the name of the module containing it. How do I fully qualify that? Do I say engine? Identifier engine is undefined. Is it lib engine, maybe? No. I don't know how to fully qualify that. Okay. All right. So I don't know. I can't get the length, which is kind of annoying. I suppose I could do it in code. All right, so the constant, linear, and quadratic of the first one. Constant is 1.0. This is quite obviously garbage. Okay, so that's not very encouraging. The color of the point light. The name is borked. Okay, so it looks like we did mess some stuff up somewhere. So that's always neat. Okay, let me check meshes real quick. So resource name is null on the first mesh that we have, which is definitely not. Parent name is also, wait, this one. So parent name is null on this one. Name is not an empty string though. So that's interesting. Transform, not looking good either. Oh. Yeah, that might be because I didn't actually put valid data in there. That's the format of it, not the actual. Okay. So I am going to cheat. And I'm going to take a look at the actual configuration that we set up for. I think the rotation on both of those things is just nothing. Actually, I know it is. So let's go 1.0. 1.0. Or no, 0 rather. 0, 0, 0.0, 1.0. So we'll go identity quaternion. Scale is going to be 1.0. 1.0. Actually, that's not true for the Sponza, is it? Sponza scale is 0.05. So that's going to be this, whoops, and this. Okay. On the XYZ, it is using quaternion identity. Okay, so XYZ is going to be this. Whoops. And that's for Sponza. Let's get rid of the F's and commas. Okay. So we have that transform. And then the Falcon. The Falcon is just position. So the Falcon is just this. So position. Right. And then identity quaternion. And 1.0 scale. Because it's not providing anything here, so that's just using the default. Okay. So that's probably part of the reason that that is not right. But that being said, I need to look into why this name is happening. So name is like messed up for like all of them, which is pretty crappy. So let's go ahead and have a look at the code. Simple scene loader, name. All right, so oh, we didn't handle. We didn't handle, wait, directional light. Yeah, we did. We didn't handle mesh though. So the root scene, yeah, we didn't handle mesh. Okay. So let me actually put that down here as well. Mesh, current mesh config. And then we're string duplicating that. So we saw that that was screwed up for directional light. I'm going to test mesh too, since that's there. Point light, I guess we can do that as well. You know what? Let's test each one of these things because I don't trust any of it now. We know that this one worked actually. Okay, so let's do that one first. You know what, before I go any further, let me make sure that none of these switch statements, switch cases, are missing breaks. I think that's the only one that really uses a switch. Okay, so we should be fine. All right, so let me run this. Oh, it's already running. Build. Run. All right, here's the game. Press L. All right, so trimmed value for this is skybox. Yeah, I said I was going to rename that, didn't I? Let me do that. So I think the skybox one was correct, but we couldn't actually verify that. So let's name it skybox 01. Kind of a poopy name, but whatever. So we're going to load. All right. So now we have skybox 01. All right. So we know that the name here is going to be set to that. All right, so that looks pretty good. Let's also check the cube map name, since I know that's what's going to be next. So we've got that. The trim value there is just skybox, so we know those are independent, correct? All right, so that's good. Let's continue on. So we have directional light. So we are filling out the directional light config name. The value here is sun. So the value there should be sun. Okay. So that one appears to be doing the thing. Mesh, current mesh config name. So this is the Sponza mesh that we're doing right now. Okay. So that worked. Okay. Now we're doing the Falcon, right? And now we're doing the point light. Another point light. Another point light. Okay. All right, now let's take a look at, so we have test scene. So name and description are good. Skybox config, name and cube map name are good. Directional light config. Yeah, see, this still is loading the name as this, which makes me think that I might have screwed up the loader code somewhere. So we'll see loader. So I think these are fine. I think it was loading the direction. No, it was loading the color. Huh, yeah, because I just copy pasta. So copy pasta strikes again. All right, so this should not be string duplicating this. This should be setting resource data, directional light, color equals, actually this is going to be a vec4, string to vec4. That is going to be trimmed value. And then the address of color. And then we'll negative check that. Okay, Warren. Format error parsing color default value used. And we'll just set this to vec for 1, which is white. Okay. So that is that. This goes away. We're also doing the same thing for point light config name, so that's why that was screwed up. So that's going to be something just like this, except it's going to go to current point light config.color. And again, we'll just reset that to, or we'll set that to white if we have an issue parsing that. Okay, what were some of the other things that we saw? Let's look at direction real quick. So direction is, that's doing the correct thing. Position is here. So position for point light, we are setting the current light config position. So that looks correct. Just making sure we don't have any copy pasta errors in here, right? Let's see. Didn't realize what time it was. I'm running over a little bit here. So let's see if we can figure this out. I'm going to try test running this real quick and just see what the data looks like now. Now that things are loading into the correct places, in theory. Load. So let's take a look at the... so name and description are still fine. Name and cube map name are still fine here. Directional light config. Now we have sun. And the color is loading what it should be loading. Those values are correct. Okay. Direction is also correct, right? So that's negative 5.7 basically on all three axes with a 0 and the W axis. So that's correct. Point lights. Point lights still look like they might be foobar, as well as meshes. So we might have a little bit of work to do there. Okay. So let's go back. And I have a feeling that since we're doing all this point light config and mesh config, that we might just not be copying that correctly or something. So when we change modes, specifically for point light, when we leave it, we are pushing the thing. Okay. We're taking the address of this, and we shouldn't be, because darray push already does that for us. And I'll bet we're doing the same thing for mesh. Right. So I've been playing around with some ideas, sort of off camera with a refactor of darray, and the new version of this that I'm thinking of doing had to take this by address. So I think I just confused that there. So I'll bet these actually work correctly now. All right. So point lights. Point light 2 is the first one. That seems... Let's do scene config point lights as an array of 3. They're all point light 2. And they're probably all the configuration for point light 2. Okay. Oh, right. I don't know if we're actually cleaning that up or not. So the position of, we'll say this is point light 0, is -5, 0, -5. -5, 0. So that is correct. The color is correct. The constant is wrong. Oh, because I'm looking for constant and not constant f. Womp womp. Okay. All right, so that's an easy fix. Linear is correct. Quadratic is correct. Okay, so I have to fix constant. And then the name I have to fix too. That's really strange that it's keeping the name for each one. But I think we're leaking memory there anyway. So let's stop this and go back. And first off, let's fix constant. This should be constant f. And in fact, I'm going to rename this property constant f. Let's just make sure that this is actually doing the correct thing. So in simple scene loader and in resource types. Yeah, okay. Accept that. Okay, so we know that's working. The only question is why is the name not working? So we have current point light config, which I didn't look at the meshes. I probably should have looked at the meshes too. I'll bet the same thing's happening there. So we duplicate the string. So I'm not understanding why it's the current point light config. Oh, we do free the name here. Just for S and Gs. I'm going to set that to 0. I wonder if because I'm reusing the same object every single time, if it's actually taking the address of this instead of the address of the string I'm creating. Interesting. Okay, so let me see if that actually makes a difference. I don't think it's going to, because we're zeroing out the thing anyway. All right, so load point light 2. All right. I wonder. So when we take that in, I think it's literally because it's the same object we're reusing. We're not seeing it for the others because we're not reusing the structure. I wonder if it's like doing some strange optimization out of that. Like, I don't think this is going to make a difference either. Right, and then set this to n. Yeah, didn't make a difference. That's interesting that it takes, whenever I string duplicate, it's creating that in the same address in memory every time. Oops, the array. We take a value pointer, we copy that memory. I'm gonna have to think of a way around that, I guess. I mean, I guess I could dynamically allocate it to get around it. That just kind of sucks. I think this is just me being tired, quite honestly. All right, let's try it with just this one, right? So I'm going to set this equal to 0. And then everything that uses it, I'll convert to a pointer. Or to treat it as a pointer. So in this case, I want to actually dereference this. This needs to be name, name, name. Okay, so we have the arrows. We don't need the address of that anymore because it is a pointer. In fact, so when we push this to the array, instead of zeroing the memory, we should free it. Memory tag, what do I want to call this? I guess I could tag it as an array. That's kind of not accurate, but All right. And then instead of this, we'll do calc size mem tag array. All right, so we'll just convert that to dynamically allocate every single time. In fact, let's switch back to doing this. Let's see. We still need the color. That just needs to be an arrow. Same thing with position. Constant F. Linear. And quadratic. All right. What did I mess up? Oh, that should be k-free. All right, let's run it. Load. Damn it. Really? What am I doing wrong here? How did that not work? These names are definitely different. We basically have the whole thing working except for this one section. Let me just double check the... Yep. I should just be taking a copy of these things. It's like because I'm using the same one. It totally doesn't make any sense. Somehow they're all winding up at the same address. All right, let me put a breakpoint here. Load. Trimmed value is point light 0. Let's do resource data point lights as an array of 3. Okay. Let's also put a breakpoint here when we go to push. Point late 0. Right? Yeah, see, it updated this pointer here. Even though this should technically be a different object. So we free that and zero it out. Guess I could try zeroing this out. I don't think that's going to make any difference, but load. All right. So push in point light 0. We continue. When we update this, still updates that. See something. You can do this one more time. All right. Load. All right. Push. All right, so that name is that. Yeah, it's the same address. That makes absolutely no sense. Unless, I can't imagine it was like a scoping thing, but what? Wait, what? Okay. Load. Push. Yeah, it updated that same address again. Well, folks, I think this is probably more than likely just due to the fact that I am exhausted and I'm way over on the stream. So I think this is probably where I'm going to call it tonight. We have it 90% of the way working, but for some reason, to do why does this always create at the same address? I'm still streaming, yes. Yeah. I'm just about to quit, yeah, for the night. Because I've been at it now for actually, how long have I been at it? Does this even tell me? It's been a bit. I don't know. 3 hours and 17 minutes. 3 hours 18 minutes. So way too long. Yeah. Yeah, so I don't know why this is always creating this at the same address. Like, that's really annoying me. And it's causing problems. So I'm going to see if I can figure that out tomorrow. But yeah, we're 90% of the way there with parsing our scene file. We have everything working except this last bit. So this is where I'm going to wrap it up for tonight. I'll push this code. I think. Are we already on? Yeah, we're already on the feature branch. This technically breaks the feature branch though. So git checkout. I'm going to say simple scene files. I'll say work in progress, simple scene file parsing, and then git push origin. What did I call it again? Simple scene files. Oops. Cool. Yeah, we can chat on Discord. I probably need to go to bed though, because it's late here. But yeah, I can chat for a few minutes for sure. All right, so that is where I'm going to wrap it up today. So what I'm going to do is I'm going to have a think about this. This is probably something really stupid that I'm just not getting because I'm tired. I've been streaming a long time. So I will think about it, and then when I come up with the answer, I will obviously bring it up on stream. But we have our file being parsed. So the next step after we get that working is to basically translate it into creating a hierarchy and then loading up all those objects as configured. So that shouldn't be too terribly difficult to do. That should probably be a lot easier than all this, actually. I don't think it's going to take as much code. So anyways, thank you guys so much for following along on the stream. I really appreciate it. I'm glad to have all of you guys here following me along. Let me see real quick if there's anybody that I want to raid. Let's do... I'm going to raid Ferret Software again. Just because it's kind of relaxing to watch, and I think it's really cool. So for those of you that don't know, Ferret Software is Pirate Software's second channel for his ferrets. So all their ad revenue and stuff from that channel goes to his ferrets for like their food and their medical bills and things like that. So I think it's a really cool thing, and I'm going to support it. And I'm also doing this because I'm tired and I don't want to hang around for a long time by raiding another stream. So anyways, I will catch you guys in the next stream. See ya.